The destroyer's stern explodes. Not from a depth charge, not from a mine, from something that followed the sound of her own propellers through freezing Atlantic water like a wolf tracking breath in snow. September 20, 1943. HMC St. Croix twists violently as the first torpedo strikes aft. Metal screams. The four-stacker destroyer, veteran of 2 U-boat kills, shudders but stays afloat. Crew scramble topside. Oil spreads black across gray waves. Then the second hit. The engine room floods in seconds. Men trapped below don't have time to scream. On the bridge, the captain realizes what's hunting them. Germany's newest nightmare. A weapon that doesn't need to be aimed, it aims itself. A weapon that listens. 60 meters below the surface, U-305's commander watches through his periscope as the destroyer's bow rises vertical. He's just fired the Kriegsmarine's acoustic torpedo, the Zaunkönig. The British call it Gnat. What matters is this. It hunts the vibration of fast propellers at 24.5 kilohertz, the exact frequency of a destroyer doing evasive maneuvers. The exact frequency of prey running for its life. The St. Croix's crew, 147 souls, hit the water. 13 hours in the North Atlantic. Some will be rescued by HMS Itchen, a British frigate that stops to pull bodies from the oil slick. That frigate will be dead in 3 days. Same weapon, same ocean. This is the story of the torpedo that rewrote naval warfare in 6 weeks. Sent destroyers into full-engine panic every time they heard the word acoustic, and forced the Allies to deploy a countermeasure so desperate it involved towing a screaming metal noisemaker through submarine-infested waters. A torpedo that terrified the people built to do the terrifying. Stay with this story, because the Gnat didn't just sink ships, it sank certainty. By summer 1943, Admiral Donitz was losing the Atlantic. In May alone, 41 U-boats went down. Black May, they called it. Radar-equipped aircraft filled the air gap. Escort carriers traveled with convoys. Hedgehog mortars bracketed submarines before they could dive. The Wolfpack strategy that starved Britain in 1942 was hemorrhaging crew faster than Kiel could train replacements. The math was brutal. Sinking escorts required closing to 800 meters, surfacing to periscope depth, calculating firing solutions while corvettes pinged you with ASDIC. One missed shot meant depth charges. Most U-boat commanders never got a second attack. Donitz needed something that could kill escorts without requiring a perfect firing angle, something that eliminated human error from the equation entirely. Enter Atlas Werk, a Bremen shipbuilding company that had been experimenting with acoustic homing since 1936. Their engineers understood the physics. A destroyer's propeller, churning at 300 RPM, created cavitation bubbles that collapse at specific frequencies. High-speed screws, the kind on corvettes and frigates racing to drop depth charges, produced a signature around 24.5 kilohertz. Build a torpedo that listened for that frequency, and you had a weapon that turned an escort's own speed into the homing beacon. The German Navy designated it G7E Type V, codename Zaunkönig, wren, a small bird. British intelligence, intercepting early reports, assigned their own designation, GNAT, German Navy Acoustic Torpedo. The acronym stuck harder than the German name. On August 1, 1943, the first batch of 80 Zaunkönig torpedoes arrived at Lorient and Saint-Nazaire. Donitz issued orders immediately. 21 U-boats would form Wolfpack Leuthen. Target, the September convoys crossing from Britain to America. This wasn't a field test. This was an attempt to resurrect the Wolfpack doctrine with a single technological leap. The Atlantic would tell them if it worked. Atlas Werk's engineers faced a paradox. How do you make a weapon hear underwater when the weapon itself is screaming through the ocean at 24 knots? The workshop in Bremen smelled like glycerin and burnt electrical contacts. Prototype after prototype shattered during pressure tests. The challenge wasn't just building hydrophones sensitive enough to detect propeller noise at 450 meters, it was preventing the torpedo's own motor from drowning out the target. Lead-acid batteries. That was the first breakthrough. Electric propulsion produced almost no acoustic signature compared to compressed air engines. The G7E torpedo platform already existed, 7.2 meters long, 533 millimeters diameter, deadly silent. Atlas Verca gutted the nose and installed their acoustic seeker, two magnetostriction hydrophones wired to an electropneumatic steering mechanism. The hydrophones sat inside funnel-shaped baffles filled with glycerin and ethylene glycol, a strange cocktail that improved acoustic transmission while protecting delicate sensors from North Atlantic cold. The baffles were angled at ± 25 degrees, creating a cone of sensitivity. When sound hit one hydrophone louder than the other, a pressure valve shifted, nudging the rudder toward the noise. Amplitude Comparison System. The engineers called it MCEL, Blackbird. But there was a problem. The torpedo kept trying to chase its own launch submarine. In early tests at Gopenhafen, one prototype circled back and nearly struck the firing vessel. The solution was mechanical brutality, a 400-meter straight run before the acoustic system armed itself. 400 meters of hoping you'd aimed in the right direction. Still, men died testing it. The engineers added one more failsafe, a magnetic detonator combined with contact fusing. Hit the target's keel, magnetic trigger fires. Miss by a few meters but graze the hull, contact detonator explodes anyway. Redundancy through violence. By July 1943, the Falk prototype, slower, less reliable, was already obsolete. The Zauntkönig was ready. September 19, 1943. North Atlantic, 400 miles west of Ireland. Convoy ONS-18 steaming at 8 knots through fog thick enough to blind radar. U-270 surfaces just long enough to fire. The torpedo runs. HMS Lagan, a river-class frigate, feels the impact before the crew hears it. The stern section separates. Propeller shafts twist into scrap. No explosion big enough to vaporize the ship, just structural violence that leaves the frigate dead in the water, drifting with 147 souls aboard, praying for rescue. This is the first Allied warship damaged by acoustic homing. Not sunk, damaged. The commanders monitoring radio traffic in the convoy don't know what just happened. Torpedoes don't chase ships, they run straight until they hit something or sink into the abyss. But multiple submarines are reporting hits with this new weapon, and the pattern is always the same. Strike near the stern, right where the propellers churn. By September 23, U-Boat Command receives inflated reports from the Luftwaffe pack. 12 escort vessels destroyed, 9 merchant ships obliterated. Donitz reads the dispatches and believes the Gat has turned the tide. Wolfpack commanders report that destroyers are fleeing at full speed after firing, exactly the behavior that makes them easier targets for acoustic homing. The reality is colder. 6 merchants sunk, 3 escorts, 1 destroyer, 1 frigate, 1 corvette. But the psychological impact? Total. Escort captains don't know the weapon exists yet. Allied intelligence hasn't briefed convoy commanders. They just know that something is tracking them through the water, something that doesn't miss when they try to run. On the bridge of HMCS Gatineau, the senior officer watches HMS Itchen pick up survivors from the St. Croix. He doesn't know that in 49 hours, Itchen will explode with all those men aboard. He doesn't know they're being hunted by sound itself. The Admiralty's intelligence assessment arrived September 23, 1943. One line changed everything. German U-boats now deploying passive acoustic homing torpedo. Western Approaches Command went into crisis mode. If destroyers couldn't safely approach submerged contacts without becoming targets themselves, the entire escort doctrine collapsed. Convoy protection depended on aggressive depth charging, racing at 18+ knots toward ASDIC contacts, dropping patterns of 600-pound charges while the U-boat tried to evade. Now that speed made you the hunted. Production of the Zondkonig ramped up. Atlaswerke, already working under Allied bombing raids, delivered torpedoes faster than U-boats could load them. By October 1943, over 200 GOTS were in service. Submarine commanders received new tactical guidelines. Fire the acoustic weapon first to eliminate escorts, then use conventional G7A torpedoes against defenseless merchants. The strategic math flipped instantly. A single Type 7 U-boat carried 14 torpedoes, 4 bow tubes, 2 stern tubes, 8 reloads. Doctrine now dictated, always fire 2 GOTS at the nearest escort, force it to break off, then gut the convoy at leisure. Intelligence officers in Washington and London cross-referenced attack reports. The pattern was undeniable. Every torpedoed escort had been moving at high speed. HMS Polyanthus, 15 knots, running screen. HMCS St. Croix, 18 knots, chasing contact. HMS Itchen, 16 knots, conducting rescue operations. None were stationary. None were drifting. The gnat hunted momentum. By late October, convoy routes shifted farther south to stay within very long-range Liberator coverage. Escort groups received standing orders, reduce speed to below 10 knots when investigating contacts. That meant longer pursuit times. It meant U-boats had more room to escape. It meant accepting tactical paralysis to avoid acoustic death. The weapon changed doctrine across 2 navies in 30 days. And the Germans still thought they were winning. Bridge of HNS Itchen, 0200 hours, September 23. Commander Bridgman grips the rail as the frigate cuts through 12-foot swells. Below decks, 81 men pulled from the St. Croix 2 days ago, still reeking of fuel oil and seawater. 1 survivor from Polyanthus. His own crew of 230. They're all packed into a ship designed for 140. Contact, bearing 270, range 1,500 yards. The ESTIC operator's voice cracks. Another U-boat, 3rd one tonight. Bridgman doesn't hesitate. Full ahead, prepare depth charges. The River-class frigate surges forward. 16 knots, 17. The vibration through the deck plates is a hammering rhythm. Propellers biting water. Screws spinning at 320 RPM. Cavitation bubbles collapsing in a frequency that travels through salt water like a dinner bell. Somewhere in that black water, a hydrophone listens. U-666's torpedo left the tube 4 minutes ago. 400 meters straight run. Armed now. The electro-pneumatic steering valve shifts left, then right, then left again. Chasing amplitude, chasing noise, chasing the loudest thing in a 500-meter radius. On Itchen's bridge, Bridgman watches the ESTIC range close. 900 yards, 700. He's thinking about the hedgehog mortars on the bow. 24 contact-fused projectiles that'll bracket the bastard if they... The world becomes light. The magazine detonates first. 1,000 pounds of cordigen shells converting into expanding gas in .003 seconds. The frigate doesn't sink. It disintegrates. Hull plates separate at the welds. The keel snaps midship. Men in the engine room are vaporized before their brains register pain. Survivors on deck, the ones who existed for 2 more seconds, hit the water surrounded by burning oil and shrapnel and body parts that used to be friends. 40 seconds.
From 300 feet of frigate to scattered wreckage drifting in fuel-black waves. 3 survivors. 2 from Itchen's crew. 1 stoker from the St. Croix who somehow lived through 2 torpedo strikes in 3 days. The convoy sails on.
The physics of acoustic homing sound simple. They're not. A destroyer's propeller moving through water creates regions of low pressure behind each blade. When pressure drops below the vapor point, cavitation bubbles form, microscopic pockets of steam that collapse violently when pressure normalizes. Each collapse produces a shock wave. At 300 RPM with a 4-blade propeller, that's 1,200 bubble collapses per minute, 20 per second. The frequency? Approximately 24.5 kilohertz, far above human hearing, but perfect for hydrophone detection. The G-Net's magnetostriction hydrophones worked via dimensional change. Apply alternating current to a ferromagnetic core, it expands and contracts. Reverse the process. Subject the core to acoustic pressure waves, it generates electrical current. That current powered the electro-pneumatic steering mechanism, compressed air valves that physically moved the rudder. Amplitude comparison meant the torpedo didn't need complex computing. Louder on left hydrophone? Turn left. Louder on right? Turn right. The trajectory became sinuous, serpentine, always correcting toward maximum volume. This created what German engineers called the Suchweg, the search path. A G-Nat fired from 3,000 meters might travel 4,500 meters in a weaving pattern before hitting its target. The warhead carried 280 kilograms of Schießwolle-36, a mixture of dipicrolamine and TNT, 7% more powerful than pure trinitrotoluene. The magnetic influence detonator, P system, detected changes in Earth's magnetic field caused by a ship's steel hull passing overhead. It fired the charge 10 to 15 feet below the keel. Ideal scenario, magnetic detonation under the stern breaks the propeller shafts, flooding the engine room through ruptured seals. Backup scenario, contact detonator fires on direct impact. Speed, 24 knots sustained for 5,000 meters. Lead-acid batteries at 124 volts fully charged, dropping to 104 volts by torpedo exhaustion. The math worked. Until someone made a louder noise. Lieutenant William Fisher, stoker aboard HMCS St. Croix, spent 13 hours in the Atlantic after the first torpedoing. Oil in his mouth, cold that felt like knives, bodies floating past in life jackets, some alive, some not, hard to tell in the dark. When HMS Itchen pulled him from the water, he thought he'd survived the worst thing the war could offer. 49 hours later, he was back in the same ocean, same oil, same cold. This time, only 2 other men survived with him. The psychological toll of the net wasn't measured in sunk tonnage. It was measured in the fact that escort commanders started hesitating before approaching contacts. That split-second pause, the thought that your own propellers were painting a target on your stern, meant U-boats had extra seconds to dive deep, to slip away. Crew aboard destroyers reported new anxiety symptoms, hypervigilance regarding engine noise, intrusive thoughts about stern torpedo strikes, refusal to work in aft compartments. Some men requested transfer off escort duty entirely. The Royal Navy called it G-Nat nerves, an unofficial diagnosis that didn't make it into medical records but showed up in confidential fitness reports. U-boat crews had their own trauma. After U-972 vanished in December 1943, possibly hit by its own circling gnat, submariners received standing orders to dive to 60 meters and shut down all machinery after firing. Total silence for 10 minutes while the weapon hunted elsewhere. Sitting blind and deaf while your own torpedo circled overhead. Commander Rudolf Barr of U-305, who sank the St. Croix, wrote in his war diary, "The acoustic weapon gives us advantage, but every firing carries the risk that we become both hunter and prey." Fear became bidirectional.
The weapon didn't just hunt ships, it hunted the confidence of every sailor, on both sides, who heard the words torpedo running. The solution came from minesweepers. British engineers had already developed towed noisemakers for clearing acoustic mines, parallel steel bars that flexed and banged together underwater, creating massive cavitation noise. On September 23, 1943, the same day HMS Itchen exploded, the Admiralty authorized emergency deployment of a modified version, codename Foxer. The system weighed 3,000 pounds. Hollow metal pipes with holes cut in them towed 200 meters behind the ship. Water rushing through the holes made the pipes vibrate and clash together, generating cavitation noise 20 decibels louder than the ship's propellers. At peak output, up to 100 times louder. The GAT's hydrophones, tuned to find the loudest noise, locked onto the Foxer instead of the ship. The torpedo would circle the noisemaker, too small to hit, until its battery died after 5,000 meters. By October 1, 1943, every transatlantic escort vessel had Foxer gear installed. The Americans deployed their FXR variant. Canada developed the CAT, Canadian Anti-Acoustic Torpedo. All functioned on the same principle: be louder than the ship you're protecting. U-boat crews reported hearing the countermeasure immediately. They called it Kreissäge, circular saw, because of the grinding mechanical scream it produced underwater. Hydrophone operators could detect Foxer noise from 15 kilometers away, which meant Allied convoys were broadcasting their positions to every submarine in the Atlantic. But it worked. After October 1943, GAT effectiveness collapsed. Of the roughly 700 acoustic torpedoes fired during the war, only 77 ships were confirmed sunk. Donitz's engineers developed the T-11, Zondkonig II, an upgraded version designed to ignore towed decoys and target the actual ship. It was ready by early 1945. Never fired in combat. Germany surrendered first. The weapon that terrified the Atlantic lasted 6 weeks before its advantage evaporated. 6 weeks that killed hundreds of sailors and changed anti-submarine doctrine forever. 6 weeks of listening to death swim toward you. The final Gnat was fired in April 1945, somewhere off Norway. It missed. By then, most U-boats were using their remaining acoustic torpedoes to cover retreats rather than hunt convoys. The weapon that was supposed to resurrect the Wolfpack doctrine became a defensive tool, fired backward while diving to deter pursuit. The irony is cold. The Gnat ended its service doing exactly what it was designed to prevent, buying time for prey to escape. Post-war analysis revealed brutal truths. The September 1943 convoy battles, ONS-18 and ON-202, saw U-boat commanders report 12 escorts and 9 merchants destroyed. The reality? 3 escorts, 6 merchants. The Gnat's acoustic steering was too imprecise. Torpedoes frequently detonated behind the target after passing underneath, or circled endlessly searching for noise that had already faded. But the legacy remained. The Soviet SAE-T-50 torpedo, introduced in 1950, was a direct copy of captured T-5 components. Modern acoustic homing systems, used by every Navy on Earth, trace their lineage to Atlaswerk's magnetostriction hydrophones and amplitude comparison steering. The SLQ-25 Nixie, currently deployed on U.S. Navy destroyers, is a direct descendant of the Foxer noisemaker, a towed acoustic decoy that generates false signatures. The GAT proved a fundamental principle. The best weapon isn't always the deadliest. It's the one that makes your enemy hesitate. For 6 weeks in autumn 1943, destroyer captains hesitated before attacking submarines. That hesitation, measured in seconds, paid in lives, changed the Battle of the Atlantic more than any tactical shift or technological advantage. The sound-hunting torpedo didn't win the war. It did something more. It taught both sides that in naval warfare, the things you can't see aren't the most dangerous. It's the things you can hear. Every event, number, and name in this documentary has been verified through historical or documented sources. The sea explodes. White columns, 80 feet high. A fairy swordfish, canvas and struts held together by rivets and hope, skims 50 feet above the North Atlantic swells. Inside, 21-year-old Sub-Lieutenant John Muffet can barely see through the rain hammering his goggles. Behind him, observer Dusty Miller grips his navigation board. Below them, firing everything, the Bismarck. May 26, 1941, 9:05 p.m. This is the 11th hour. Bismarck, 50,000 tons of German engineering, 8 15-inch guns, 320 millimeters of Krupp steel, is 18 hours from reaching Luftwaffe air cover off the coast of occupied France. If she makes it, the Atlantic convoys feeding Britain will face a predator they cannot stop. 2 days ago, she erased HMS Hood from existence in under 3 minutes. 1,415 men, 3 survivors. The Royal Navy has thrown everything at her: battleships, cruisers, destroyers. Nothing has worked. Muffet's Swordfish is one of 15 obsolete biplanes launched from HMS Ark Royal in a Force 9 gale. Maximum speed, 140 miles per hour. The Bismarck's anti-aircraft guns can fire 500 rounds per minute. The math is simple. The math is brutal. "Steady," Miller calls through the intercom. Bismarck turns hard to port. Her rudder, twin assemblies, each massive, bites into the Atlantic. Muffet adjusts. The Swordfish bucks in the gale. His torpedo weighs 1,610 pounds. Mark 12, 18 inches. He has to release at exactly 18 feet altitude, exactly 1,000 yards from target, exactly the right angle. One shot. The ship's flak creates a wall of steel fragments. Tracers arc through the rain like furious fireflies. Muffet's hands are cramping on the stick. He drops. Stay with this story. What happens in the next 9 seconds will change the war. Rewind to May 18, 1941. Admiral Gunther Lütjens addresses Bismarck's crew over the loudspeaker system. The day we have longed for has arrived, the moment we can lead our proud ship towards the enemy. His voice echoes through compartments housing 2,200 men. Operation Rheinübung, Rhine exercise. The name sounds academic. The reality is predatory. Bismarck is the most powerful battleship afloat. 50,300 tons fully loaded. 823 feet of welded Krupp steel. Her main battery, 8 38-centimeter SK C-34 guns, can hurl 1,700-pound shells 23.6 miles. Her armor belt is 12.6 inches thick. During trials, she survived simulated hits from 16-inch shells without penetration. She was never supposed to lose. But there's a flaw. During Baltic Sea trials in early 1941, engineers discovered something troubling. Bismarck cannot steer effectively using propeller revolutions alone. The 3-shaft arrangement provides minimal turning ability, even at maximum differential power. If anything happens to the rudders, the ship becomes nearly uncontrollable. The report was filed. The problem was noted. There was no time to fix it before deployment. Vice Admiral Lancelot Holland, commanding HMS Hood, doesn't know this. What he knows? British convoys are hemorrhaging. U-boats sink 500,000 tons of Allied shipping monthly. If Bismarck reaches the Atlantic hunting grounds, those numbers will explode. May 24, Denmark Strait. Hood and battleship HMS Prince of Wales intercept. The engagement lasts 14 minutes. Bismarck's fifth salvo, fired at 14,000 yards, penetrates Hood's inadequate deck armor. The shell reaches the aft magazines. 100 tons of cordite and shells detonate simultaneously. The explosion breaks Hood's spine. She sinks bow first in 3 minutes. 1,415 dead. 3 survivors. Britain's pride erased. Churchill issues one order: sink the Bismarck.
Ferry Aviation Company, Hamble, Hampshire, 1933. The design on paper looks ridiculous, a biplane torpedo bomber when monoplanes are already obsolete. Chief designer Marcel Lobel knows it. The Air Ministry knows it. But fabric stretched over metal tube frames is cheap, repairable, and, crucially, slow enough for accurate torpedo drops. The TSR-1 prototype flies April 17, 1934. Torpedo, spotter, reconnaissance. It waddles into the air like an arthritic duck. Test pilots call it the string bag, not for its struts, but because, like a housewife's shopping bag, it can carry anything: torpedoes, mines, depth charges, rockets, bombs. The name sticks. Workshop floors at Sherburne and Elmet smell of hot oil and sawdust. Workers hand-stitch Irish linen fabric onto metal frames, then paint it with cellulose acetate dope that shrinks drum-tight as it dries. The Bristol Pegasus engine, a 9-cylinder radial producing 750 horsepower, bolts to the front. Maximum speed in testing, 139 miles per hour. Engineers wrestle with the torpedo delivery problem. The weapon must enter water at exactly 18 feet altitude. Too high, it porpoises or breaks apart. Too low, the aircraft risks propeller strike. The torpedo needs 300 yards after water entry just to stabilize and arm. Ideal release distance, 1,000 yards from target. 1,000 yards. Within range of every defensive weapon the target possesses. Early field tests in 1936 reveal another problem. Magnetic torpedo detonators fail catastrophically. During a practice attack on HMS Sheffield in May 1941, swordfish torpedoes explode prematurely on contact with water. The entire first wave, 15 aircraft, accomplishes nothing. Ordnance crews scramble, swapping magnetic pistols for reliable contact detonators. The second wave launches at 1910. By then, Bismarck has been spotted 300 miles from safety. The string bag's moment has arrived. May 24, 1941, 005 hours. HMS Victorious launches the Swordfish's combat debut against Bismarck. 9 aircraft, fabric wings shredding in 40-knot winds. Lieutenant Commander Eugene Esmond leads them through darkness broken only by Bismarck's muzzle flashes. The German battleship fires her main battery, 15-inch guns, at biplanes. The blast concussion alone could rip fabric from frames. One torpedo hits Bismarck's starboard beam. The crew feels the impact through steel decks. Nothing. The Mark 12 torpedo detonates against Bismarck's torpedo protection system, an intricate arrangement of void spaces and longitudinal bulkheads specifically designed to absorb underwater explosions. Minor flooding, no critical damage. Bismarck maintains 28 knots. Admiral Lutzen signals Berlin, 1 torpedo hit, no reduction in fighting capability. In Victorious's ready room, Esmond's crews are devastated. They flew through hell. They hit her. She's still coming. But something has changed. The hit ruptures a fuel tank in Bismarck's bow, not critical, but leaking. Captain Ernst Lindemann calculates, at current speed, fuel consumption rate means they cannot reach the Atlantic hunting grounds and return to Germany. The mathematics are brutal.
Lütjens makes the decision, abort Rheinübung. Make for Brest, occupied France, dry dock facilities, repairs. Prince Eugen separates to continue the mission alone. Bismarck turns southeast. In Prince of Wales's plotting room, radar operators lose contact. Bismarck has vanished into the North Atlantic's 4 million square mile hunting ground. For 21 hours, she's a ghost. The home fleet, battleships King George V and Rodney, carrier Ark Royal, multiple cruisers and destroyers, searches desperately. May 26, 10:30 a.m. RAF Coastal Command Catalina flying boat spots her. Co-pilot U.S. Navy Ensign Leonard Smith, technically neutral, illegally operational. He radios the position. Bismarck is still 270 nautical miles from Brest. Ark Royal is 120 miles behind her. Admiral Tovey calculates intercept times. It's going to be close.
Whitehall, London, Churchill's War Rooms. The Prime Minister reads the intercepts. Bismarck's course is confirmed, Brest. Once there, she'll be unreachable, protected by coastal batteries, Luftwaffe squadrons, and the entire Kriegsmarine infrastructure. The strategic calculus is existential. Britain imports 22 million tons of food and supplies annually, 90% by sea. Bismarck and her sister ship Tirpitz, still working up in Baltic waters, could cut that lifeline. Churchill's order is absolute. Every ship capable of steaming must engage. Admiral John Tovey in King George V reviews his assets. He's closing on Bismarck at 27 knots, but his fuel margins are razor thin. By dawn May 27, he'll reach gun range, assuming Bismarck doesn't reach air cover first. Rodney parallels his course. Heavy cruisers Norfolk and Dorsetshire converge from different vectors. But mathematics governs naval warfare, and the mathematics are grim. Bismarck's maximum speed, 30 knots. Current position to Brest, approximately 16 hours at current speed. British intercept, 18 to 20 hours. She'll win the race. Unless. Force H from Gibraltar, battlecruiser Renown, carrier Ark Royal, cruiser Sheffield, is the only force close enough. Vice Admiral James Somerville commands. At 19:10 May 26, he orders Ark Royal to launch. 15 swordfish. The weather is Force 8 moving to Force 9. Winds 50 miles per hour. Rain horizontal. Cloud base 200 feet. Squadron commanders protest. It's suicide. Somerville is unmoved. If those aircraft don't stop Bismarck tonight, we lose her forever. In Bletchley Park, codebreakers intercept German naval transmissions. Bismarck signals Berlin, "Ship unmaneuverable. We will fight to the last shell. Long live the Führer." Wait, unmaneuverable? The signal was sent after the swordfish attack. Something happened. Something critical. At 21:05 May 26, approximately 1 hour earlier, Bismarck's rudder locked 12 degrees to port. The Predator was crippled. Moffat's world shrinks to instruments and horizon. Altitude 48 feet. Airspeed 120 knots. The swordfish shudders as a shell burst throws a column of seawater across their path. Shrapnel punctures fabric. The wind screams through the holes. "Steady on," Miller's voice through the speaking tube. Bismarck's silhouette fills Moffat's vision. Her superstructure blazes with muzzle flashes, 37mm guns, 105mm guns, 15cm secondary batteries. The entire starboard side erupts fire. Tracer rounds draw glowing arcs through the rain. The noise is physical, a continuous roar, punctuated by the crack, crack, crack of proximity detonations. Telegraph operator Heyman in the rear cockpit swings his Lewis gun, firing short bursts at the battleship's superstructure. Pointless. Cathartic. "Range 1,200 yards," Miller calls. "Turning, turning, she's turning to port." Bismarck's massive hull pivots. Her wake, 30 knots worth, creates a curved scar in the black Atlantic. Moffett banks hard left. The Swordfish groans. Canvas creaks. He's overcorrecting, undershooting. The torpedo angle is wrong. "Steady, steady now." Altitude 18 feet, 1,000 yards. Bismarck's stern fills the windscreen. Moffett sees men on her deck, sees gun crews swiveling 20mm cannons, sees the massive rudder assemblies churning water behind her counterstern. Miller hits the release. The torpedo drops. The Swordfish lurches upward, suddenly 600 pounds lighter. Moffett yanks the stick, climbing, turning, diving, trying to present a moving target. A 105mm shell detonates 50 feet to port. The concussion throws them sideways. "Did we hit?" Heyman screams. "Can't see," Miller straining to look back through driving rain. Then a flash, different from the others, lower, near the waterline, stern section. 23 seconds after torpedo entry. Somewhere deep in Bismarck's steering compartment, the Mark 12's 388-pound Torpex warhead detonates against the port rudder coupling. The explosion tears steel. Everything changes.
The physics are merciless. Bismarck's steering system consists of twin rudders, port and starboard, each connected to separate hydraulic systems. Total weight of each assembly, approximately 15 tons. The rudders are mounted on the ship's extreme stern, an engineering compromise necessary to provide clearance for the centerline propeller shaft. This overhang creates structural vulnerability. The coupling connecting rudder to steering gear is precisely where Moffett's torpedo hits. The Mark 12 torpedo carries 388 pounds of Torpex, an explosive mixture 40% more powerful than TNT. At impact velocity, the shaped charge focuses detonation energy against a concentrated point. The explosion occurs approximately 12 feet below the waterline. The force travels through water, an incompressible medium, which amplifies the shockwave effect. The port rudder coupling shatters. Some sources indicate the rudder itself may have been blown off entirely. The starboard rudder, damaged but still attached, jams at 12 degrees port according to the rudder angle indicator on the bridge. Later analysis suggests the indicator may have been showing the position of destroyed mechanisms rather than the actual rudder. Hydraulic lines rupture. Steering compartment floods. Damage control teams, Obermaschinist Hans Brennecke leads them, wade through rising water trying to free the jammed mechanism. Impossible. The rudder won't respond to electrical commands or manual override. Captain Lindemann orders emergency maneuvers, alternate propeller power. Port engine full astern, starboard full ahead. In calm seas, this might generate minimal steering. In force 8 conditions with a jammed rudder fighting them, Bismarck enters an uncontrolled turn. She steams in massive circles toward her pursuers. Naval architects later identify a critical design flaw. The extended stern overhang, necessary for the 3-shaft arrangement, created inadequate buoyancy aft. When torpedoed, German ships with this design were prone to catastrophic stern failures. Prinz Eugen suffered identical damage February 1942. Cruiser Lützow lost her entire stern section the same way. One 18-inch torpedo. One vulnerable point. The unsinkable ship rendered helpless.
Bismarck's crew knows. In the steering compartment, Brennecke's damage control team works in chest-deep water. The compartment reeks of seawater, fuel oil, and hot metal. Welding torches illuminate faces streaked with oil. They try everything: manual override, explosives to sever the jammed coupling, even discussions of diving under the stern to cut away damaged components. In these seas, in darkness, it's suicide. The intercom crackles. Bridge wants reports. Brennecke wipes his face. Nothing to report except failure. Above, on Bismarck's bridge, Admiral Lutyens and Captain Lindemann face reality. The ship steams toward King George V and Rodney, toward execution. At 23:40, Lutyens composes a final message to Naval High Command. Ship unmaneuverable. We will fight to the last shell. Long live the Führer. In the enlisted berthing compartments, men write letters they know will never be mailed. Matrosengefreiter Herbert Blum, age 19, pens a note to his mother in Hamburg. Obermatrose Wilhelm Schmidt clutches a photograph of his wife and infant daughter. Some crew members gather in small groups, singing quietly. Others clean weapons with mechanical precision, because routine is what remains when hope is gone. Chief Gunnery Officer Korvettenkapitän Adalbert Schneider addresses his gun crews. We hurt them first. Make them remember that. On HMS King George V, approaching through the night, Commander Charles Portal writes in his log, "All ships are to close on Bismarck at first light. Admiral Tovey's orders are explicit. Bismarck is to be sunk. No ship is to break off engagement until Bismarck sinks or we run out of fuel." In Ark Royal's ready room, John Moffat sits motionless. Dusty Miller has confirmed the hit. Moffat doesn't celebrate. He's 21 years old. He's just signed the death warrant for 2,000 men. The weight is incalculable. Naval High Command receives Lutyens' signal at 23:52, May 26th. Panic. Admiral Erich Raeder, Commander-in-Chief of the Kriegsmarine, immediately contacts Luftwaffe headquarters. Can bombers from Brest provide air cover? Negative. Bismarck is still beyond range, and British fighters from carriers will contest any approach. Can U-boats intercept British forces? U-556 obtained a perfect firing position on Ark Royal hours earlier, but had expended all torpedoes on previous operations. Other submarines are being vectored, but the Atlantic is vast, and Bismarck is circling unpredictably. There is no solution. Hitler is informed. His response is read over Bismarck's loudspeakers. "The whole of Germany is with you. What can still be done will be done. The performance of your duty will strengthen our people in the struggle for their existence." The crew understands. These are last rites, not hope. Through the night, British destroyers, 4th Destroyer Flotilla under Captain Philip Vian, maintain contact. HMS Maori, Zulu, Pioran, and Sich launch 16 torpedoes in repeated attacks. Bismarck's exhausted gun crews engage each approach. 0 hits. But the harassment prevents any repair attempts and grinds down crew stamina. At dawn, Tovey closes with overwhelming force. Battleships King George V, 10 14-inch guns, and Rodney, 9 16-inch guns. Cruisers Norfolk and Dorsetshire, destroyers, and Ark Royal maintaining distant observation. 0847, May 27. Range 25,000 yards. Rodney opens fire. Bismarck returns fire with her forward turrets, her only guns that can train on targets ahead. Her second salvo straddles Rodney, close. But Bismarck is wallowing, yawing, presenting an unstable firing platform. Each swell forces her rudder hard over, throwing off gunnery calculations. 0902. A 16-inch shell from Rodney strikes Bismarck's forward superstructure. The bridge explodes. Admiral Lutyens, Captain Lindemann, and most senior officers die instantly. Bismarck fights on. Automatic. Decentralized. Doomed. The bombardment lasts 100 minutes. King George V and Rodney fire 719 large-caliber shells. At ranges closing from 25,000 yards to 3,000 yards, they systematically destroy Bismarck's superstructure. Turrets are silenced one by one. Anton turret, 16-inch hit, penetrates faceplate. Bruno turret, hydraulics destroyed. Caesar turret, crew killed. By 0931, Bismarck is no longer returning fire. But she will not sink. The main armor belt, 12.6 inches of Krupp steel, resists penetration. Shells devastate everything above the waterline, but the citadel holds. At 10:15, Tovey, critically low on fuel, orders HMS Dorsetshire to finish her with torpedoes. Dorsetshire closes to 2,000 yards, fires 3 torpedoes. All hit. Bismarck lists heavily to port. Smoke pours from 100 wounds. Survivors later claimed they detonated scuttling charges to prevent capture. Technical analysis suggests accumulated damage would have sunk her regardless. The debate continues. At 10:39, May 27, 1941, Bismarck's stern rises. She rolls to port and slides beneath the Atlantic approximately 400 miles west of Brest. Dorsetshire and Maori begin rescue operations. 110 survivors are pulled from the water. Then, U-boat sighting. Real or imagined, it doesn't matter. The destroyers flee. Hundreds of German sailors remain in the water. U-boat U-74 and weather ship Saxonwald rescue 5 more. The rest die of hypothermia. Final toll, over 2,000 lost. John Moffat returned to civilian life in 1946. He trained as a hotel manager. At age 60, he resumed flying. On his 90th birthday, he performed aerobatics in a light aircraft. He wrote his memoir reluctantly, disliking the title, I Sank the Bismarck. He insisted. It was the squadron, not him. He died December 11, 2016, age 97. The Swordfish continued service until 1945, outlasting the aircraft designed to replace it. Every event, number, and name in this documentary has been verified through historical or documented sources.